This video is about multiplying and dividing with significant figures. It's not so much about the actual act of multiplying and dividing, because that's easy. Plug it into your calculator, you got it. This video is more about how do you represent your final data with the correct level of precision given the data that you have collected. So for instance, in this case here, this top one, it looks like we got some volume data and some density data. The density data is given to us in two significant figures. I highlighted both of them. And the volume data is given in three significant figures, just like so. This multiplying and dividing is a lot easier than adding or subtracting because you don't have to worry about what place it's in, like the tenths or the hundredths or the thousandths or the ones or the tens. All that matters is the total number of significant figures. So in this operation here, we know that 5 times 2 is 10. No problem. We also know that the milliliters cancel, giving you grams here. Now the question is, how many significant figures should this number be recorded in? And that is done by the following. You have 3 significant figures here, 2, and with multiplying and dividing, you have to record your number in the least amount of significant figures. So in this case, you have to record that answer in 2 significant figures. Now what's interesting about the number 10 is that 10 has, right now, as written, has only 1 significant figure. So right now, we're not doing it enough justice. And so therefore, the way that we would do that is twofold. One, we would say 10 grams. That's one way. Or the other way is to go 1.0 in scientific notation times 10 to the 1 grams. Typically, it's generally written in scientific notation. That's generally how they do that. But you could also do it as a top. You would not want to do this 10.0 grams because that would show 3 significant figures, and that is not good because we have to show it in 2 significant figures. Okay, that's the first example. Easy. Find the number of the lowest number of significant figures, and that's what you record your final answer to. A great prime example of this is the following 2 examples, where 0.15 divided by 3 is going to be the same answer. It's 0.05 to both cases. And that'd be centimeters per second, like so. Now the question is, how do we do this for each problem? Well, this second problem, we look at this number right here. This has 2 significant figures. This has 1 significant figure. Therefore, you're going to round this number right here to 1 significant number. 1 significant figure because that's the least precise measurement that you have. And so therefore 5 is the first significant number here. These 2 zeros are not significant. So therefore that is the answer to this problem here. This problem, however, 0.15 still has 2, but 3, and the 0 is to the right of the decimal and to the right of the last significant number, meaning that that is also significant. Therefore, the least precise measurement is 2 significant figures. Well, if I have 5 here, then what I have to do to make this significant is add another 0 afterwards, and then that would now be correct. The difference between these is this answer right here, the bottom one, is more precise because it has a more precise measurement, allowing me to be more precise in my final answer. The final example that I'll do here is as follows. It's scientific notation. When I multiply this, I just did this quickly on my calculator. It's 16.65 times 10 to the 8th. And the seconds will cancel, leaving you with meters. So that's how far light would travel in 5.5 seconds. But I want to make sure that this is written in correct scientific notation. So I got to make this smaller, which means I got to make that bigger. So that'd be 1.65 times 10 to the 9 meters. If you have any questions on that stuff, you can check out my scientific notation videos. But that is the distance that it would travel. Now, the question becomes, how many significant figures? Well, over here, this has 2 significant figures. This has 3 significant figures. Therefore, you'd want to record this in 2 significant figures because that's the least precise measurement that you have. So over here, you go 1, 2. That 6 needs to get rounded up, so therefore it would be 1.7 times 10 to the 9 meters. And that is it. This is basics of multiplying and dividing with significant figures.